Hello everyone, and today I want to talk to you about the Android anatomy, and we'll focus on some of the key features of the platform and some of the components as well, okay? So the agenda for today will be a quick cover of and a quick look at the platform fundamentals. We'll look at the Android application components, and then we'll have a look at the Android lifecycle, which is quite important also, which so for developing our Android apps, whether they're very simple ones or very complex ones, we still need to know about the Android lifecycle and what kind of methods, functions are there that we can use and leverage within our app, okay? So to begin with, to have a quick look at the platform fundamentals. Android is an open source Linux-based software stack created for a wide array of devices and form factors, all different kinds of devices, different sizes of devices. So if we have a quick look at the different kind of layers that are within it, okay? So we have our system apps layers at the top. We will have the Java API framework. So it's generally you as a developer will be working through or with these two layers mainly, okay? It's worth knowing about these layers, so the native libraries and the ART or Android runtime and some of the core libraries, and then we're getting closer to the kind of hardware side of stuff there. So we've got our hardware, our abstraction layer, HAL, and we've got a Linux kernel as well there. So this is for all your device drivers and all the rest of it. So we'll talk a little bit about each, and then where necessary, we kind of just focus on what's more specific to us as developers, okay? So to begin with, if we have a look at the Linux kernel, so we kind of start from the bottom up. This is the foundation of the Android platform. Allows Android to take advantage of key security features and allows device manufacturers to develop hardware drivers for a well-known kernel. So the likes of your Sony, likes of your Samsung, HTC, Huawei, they're all developing drivers for this particular kernel, so that obviously keeping costs down as well, okay? Which this is very different to kind of the iOS world, where it's all built into the hardware and the software are all in the one device. Whereas in Android, and that's why so many different manufacturers can actually build this stuff. We would have talked about this in previous sections as well, but it's because Android is based on this open source software stack that you, even as a developer, if you want, can kind of swap in and swap out individual kind of components and elements of the layer, okay? So that's the first one, the Linux kernel. Second one there, hardware abstraction layer, or HAL for short. So standard interfaces that expose device hardware capabilities to the higher level Java API framework. Multiple modules, each implementing an interface for a specific type of hardware component. And then the modules are loaded on demand. So if you can see it there, again, we would have our kind of our audio, our Bluetooth, our camera, the different sensors, the Wi-Fi stuff will be in there as well. Your network provider, whoever you're kind of you're dealing with for your service, would all kind of would be kind of built into that particular layer. Again, developers don't really need to know too much about that. But it's worth knowing or worth being aware that the layer is there, especially if you're kind of you might have debugging your application, and kind of these hardware errors might pop up that at least you might have a place where to start to try and debug that issue. Okay. We then have our Android runtime, or ART for short. So each app runs in its own process and with its own instance of the ART, the Android runtime. Okay, executes DEX files. This is short for Dalvik executable format. It's like your basically the format. It's like your .exe with programs, or a .app on a .exe on Windows machines, and kind of a .app application on kind of iOS machines. Okay, DEX is a bytecode format designed and optimized for minimal memory footprint. Just other points to note as well over here. Excuse me, the runtime itself converts DEX files to more compact machine code via ahead of time AOT or just in time compilation. Has optimized garbage collection and has debugging support, profiler, diagnostic, and crash reporting. So I suppose, again, from our point of view, developers' point of view, we don't need to know too much about this, but it is worth being aware that this is what when our users would download your app from the Play Store. This is what gets compiled at just in time and ahead of time. So in the latest version with Android runtime, it's compiled. It's partially compiled when it's available on the Play Store, and when it's actually downloaded, then it's that ahead of time and just in time compilation to customize it for the device that the user is running it on. So again, I don't need to know too much about this, but worth being aware of it. Okay. We then have our native C++ libraries. So many core components are built from native code that require native libraries written in C and C++. And if you need to, you can actually write some of those components yourself. Again, remember, it's open source. You can swap in, you can swap out some of these components. So if you need to write a specific one yourself that is relevant to your specific app, you could actually do that in native C and C++. Okay. Some of these are exposed as a Java framework APIs. So again, if you are, just to highlight that specific one there, our OpenGL. Right. If you need to do some kind of fancy graphics, and if you're looking at writing a game with 2D and 3D graphics, that's the particular element of the framework that you would be working with. So if necessary, you could actually write some elements yourself to enhance whatever you need to do. Okay. Most of the time you won't have to, but in certain situations, especially if you're looking at writing some kind of a game that would have 2D, 3D elements in it, you might need to kind of customize something there yourself. Okay. We then have what we kind of focus on specifically as the developers. We have the Java API framework. So again, you can see, as I said, what it's made up of. We'll talk about these in later slides. Content providers, we have the view system. So again, a view, basically all those widgets, all the everything related to the UI. We have all our different managers then. See them here. Right, our activity manager, and we'll talk about what activities are specifically in more detail later on. Location, if you're looking for location awareness, look, all the different resources. So that's all the elements that essentially that the user sees on a screen. Even talking about your telephony, your notifications, a couple more other ones in there as well. All these different managers, and so you as a developer would work directly with these APIs to build your app. So a huge part of Android development is understanding and being aware of what APIs are available to you and how to use them. Okay, location would be a great example there. That in the past, the location, and we will cover this in later sections possibly. In the past, location was there was a lot of boilerplate code. There was a lot of checks and I suppose things that the developer would have to focus on. Very simple. What's the best signal? Is it Wi-Fi? Is it network? Is it GPS? In the latest version of the APIs, a lot of that is looked after by a thing called the Fuse Location Provider. So that's taken away a lot of that extra overhead and kind of shifting the burden, shifting the workload back into those APIs. So it's part of the developer's job, I suppose, to be aware of the changes. First of all, what API is there, how to use it, and then the changes in those APIs through the different versions. Okay, so if we look specifically at some of the points we're making there, they're basically the building blocks for Android apps. They encapsulate lower level components and services, and we have all the different ones there as we're highlighting. There's our view system to build an app's UI, including lists, grids, text boxes, buttons, and even an embeddable web browser. We have a resource manager, which provides access to non-code resources such as localized strings, graphics, and layout files. Colors will be in there as well. Even if you wanted to have some audio and video, that would kind of fall under that heading as well. But everything would refer to them as a resource. We have our notification manager. There we have it just highlighting there. Enables all apps to display custom alerts in the status bar. So the same way you would get a notification that you've just received a new email via Gmail or whatever, you can write your own notifications as well, and that would all be looked after within the notification manager. So you then, as the developer, would have to become familiar with the notification manager API. Last view there, we have our activity manager, which manages the life cycle of apps and provides a common navigation backstack, and we will focus on that life cycle in this section here, just near the end of the slides. And then finally, our content providers, and we will focus on those a little bit now later on as well, enables apps to access data from other apps, e.g. Contacts app, or to share their own data. So the content providers, are a very nice way to share information, share data between apps. And we talked that there's other issues about security and about principle of least privilege, but to get around that, content providers are quite useful. Okay, and so we'll talk about those in due course. We also then have our at the top of the layer are the system apps, and these are basically the apps that the user uses. Okay, so it's we have a set of core apps for email, SMS messaging, calendars, internet browsing, contacts, etc. We refer to those as our kind of our native apps. Okay, these apps have no special status among the apps the user chooses to install. So whether it's a third-party app, whether it's a built-in native core app, the operating system doesn't differentiate between them. Okay, these are apps for users, and they provide capabilities that the developers can access. So just a final point to note there, a third-party app can become the user's default web browser, SMS messenger, or even the default keyboard, right? But some exceptions do apply, right? Such as the system settings apps. You can't really change the settings app. Most of the other ones you can, okay? Again, because this is open source, and because the core, the native apps have no special status, as we've mentioned there, versus any other apps that the user wants to install, okay? So the user, if you were building your own SMS messenger, your own messenger app, the user could decide to set that as the default app with very minimal kind of setup. Okay. So just to recap there, look at it all again from the bottom up. We have our Linux kernel, our HAL, we have our native libraries, Android runtime, and then where we work with most of the time as developers with the system apps, and then the Java API framework. So as I said, a huge part of Android development is just being aware of the Java API framework and all the classes that are in there to help you solve the particular problem that you want to solve. Okay. Now let's have a look at some of the Android application components. Okay, so to begin with, it's kind of the main one there, the one that the user will actually install, is the application itself. Can be written using Kotlin, Java and C++ languages, right? The Android SDK tool compiles code along with any data and resources files into an APK. So that's like your .exe that you have on a Windows machine, which is an Android package, which is an archive file with a .apk suffix, okay? One APK file contains all the contents of an Android app and is the file that Android powered devices use to install the app. So this is what, when the user goes to install your app from the Play Store, that's what actually gets downloaded onto the device, and that's what gets installed. And what it's actually made up of is generally what we have here in this little graphic. So we have our manifest file. We won't go into too much detail, but for the moment, just kind of be aware that the manifest file is like the metadata about your app. So we'd have things like we have it just highlighted there, kind of the permissions maybe that your app has. So can it access the internet, can it access location, things like that. The different components. So does it have, it would have to list off all the different activities. Again, we'll talk about activities in a minute. So all those, any activity that you have inside your app would have to be listed in there. Also things like the version of your app, version number, which would tie back to the Play Store again, an individual package name, which ties in with actually hooking into some of the Google Play services, all the features. Getting down to some of the specifics, we have a kind of an assets folder, which would be all the different asset files that are associated with your app. We would have the meta-inf signatures, which would, again, maybe if you had Google Maps, you'd have a Google Map key tied to that there, kind of embedded in the APK. Your individual libraries that you might be using, the actual bytecode itself of all the different classes, and the compiled code that we'll be running, are different resources, which would be the kind of the flat raw resources like your images, any little graphics you have in there, maybe your colors, kind of any text, any strings that you would have been developed, any kind of widgets, UI elements that would be displayed on your app. And then finally there's those compiled resources in a resource.arsc file. Okay, so that now look, the user never sees any of this stuff. This is all bundled up inside that single APK file, which is what the user would download from the Play Store and install on the device. From the developer's point of view, when you are running your and building your app in Android Studio, if you actually keep an eye down in the bottom bar of the window as it builds, you'll see installing APK on your emulator or on your actual device. And that is a single file that you can find, and if you need to, you could actually email that file to someone else And if they had an Android device and they opened it through Gmail, the device would pick up that it is an Android app you're trying to install and would ask you if you want to install it. So it's a very nice way if you need to share your app, or if you need to install your app on another device that's not your own device, you could simply email it. And we would have covered that in previous sections as well. Just to continue on, so to talk a little bit about the security model, okay? So each app lives in its own security sandbox, protected by a range of security features, okay? It's assigned a unique Linux user ID, so the system sets permissions for all the files in an app so that only the user ID assigned to that app can access them. Each app is a process with its own virtual machine, its own VM, so an app's code runs in isolation from other apps, and that has its kind of pros and cons, okay? Just a final point there on that the app is started when any of its components need to be executed, and the app is shut down when it's no longer needed, or when the system must recover memory for other apps. Now, there's a very important point here. Because each app has its own process and runs with its own virtual machine, when it's shut down, that is destroyed, and so the process is destroyed. So if and when the user launches your app again, so for argument's sake, maybe your app was paused while the user was taking a call, and then the user returned back to your app, and we'll talk about that in the life cycle now in a minute. But when your app would return back to, shall we say, the foreground and back to the app that the user is currently using, that may be a new process. So you as a developer have to be very aware of, was the user working with data, or did data need to be saved? Because it isn't just automatically backed up, because of that fact that it could be destroyed because the process is destroyed. So you need to ensure that your data would be, as I say, temporarily backed up in temporary storage, so that when the app comes back, the data is loaded back up. Very simple example, maybe the user was filling in a form and they had a name and an address and a phone number. You as a user would expect those fields to still be there when the app returned, but that doesn't happen by itself. You as a developer have to build that in because of this particular security model that's in place, okay? We've also got this notion of principle of least privilege. So each app by default has access only to the components that it requires to do its work and no more. This creates a secure environment in which an app cannot access parts of the system for which it is not given permission, and that those permissions are very, very important. However, there are ways for an app to share data with other apps and for an app to access system services. An app can request permission to access device data, such as the user's contacts, the SMS messages, and then the mountable storage, which might be on your SD card, the camera, Bluetooth, etc. The user has to explicitly grant these permissions. So when you are, if you've ever noticed it, and I suppose something to think about yourself as well, whenever you are installing an app, an Android app on your device, do you actually read the permissions and read what the app is looking to access? Because once you install that app and you grant those permissions, it does have access. So if the app is looking for your access to your contacts, if it's looking access to your SMS messages, when you say OK and say install, that app has direct access to all that information. So when you are writing your own app, if it's sitting on top of that and you need other extra permissions like location, like the camera, whatever, you have to, that's not granted by default. You have to explicitly ask in your app for access to those particular elements, like the camera, like again Bluetooth, like location or whatever. Okay, so permissions are a big part of any complex app that uses some of those sensors, some of those devices, elements, components of the hardware elements of an Android app. Okay. So to talk a little bit about the Android components themselves, okay, so app components are the essential building blocks of an Android app. Each component is an entry point through which the system or a user can enter the app, and each type serves a distinct purpose and has a distinct life cycle that defines how the component is created and destroyed. So we'll have a look. There's four main ones over here. We have our activities, which we'll kind of focus on in some detail. We have our services, which are things that kind of run in the background. We have our content providers, which are again ways of sharing data between apps. And then we have our broadcast receivers, which kind of ties in with the notifications. So if there are components that you would build into your app to listen for these notifications and then respond to those notifications in a certain manner. Okay, so to look at another graphic that kind of gives you a little bit of detail of what they all are. So these are kind of our main Android components. So if we look at the activities there, we'll go into these in a little bit more detail, but just to focus on them initially, we have our activities. So an activity represents a single screen with the user interface. In short, activities perform actions on the screen. Again, we go into those now in a lot more detail because these form a huge part of any Android app. We have our services. It's a component that runs in the background to perform long-running operations, so possibly downloading some audios, even some video file from the internet. We have our broadcast receivers. So they simply respond to broadcast messages from other applications or from the system. So again, notifications would be a very common kind of example of those broadcast messages. And then you write your broadcast receiver to respond to that notification. We have our content providers. So a content provider component supplies data from one application to others on request. And then finally there we have additional components. They don't fall under the kind of the main components, but they do make up your apps. So these are additional components which will be used in the construction of the above mentioned entity. So we have other elements that would be used to work with activities, services, broadcast receivers, and finally their content providers. Okay. So just to continue on there. So if you have a look at activities, okay, so an activity is the entry point for interacting with the user. It represents a single screen with the user interface. Activities work together to form a cohesive user experience. So an email app might have one activity that shows a list of new emails, another activity to compose an email, and yet another activity for reading emails. So from our point of view, every screen that you want to build, that you want to have in your app, is an activity. And that activity is a class which will control the screen itself, the UI elements, and also tie back to kind of data in the background itself. Okay, so to begin with, we might have some quite basic screens with some basic widgets, or we could actually progress onto some quite complex apps. And as you can see there in the example, we're using Gmail as a nice example there. So we have our initial kind of a list, which would be one activity, just kind of listing a summary of all this, the emails that we have in one activity. We might have another activity that allows you to go in and view them individually and look at more detail. Okay, so you kind of, when you're deciding on the type of app you want to build, you're probably better off, and we would have covered this in the design section as well, you're probably better off just kind of sketching out how you want your activities to look, how you want your screens to look, and then once you've decided on a nice layout, you can then go and build the activities, which will be and control the screens that the user sees. Okay, let's talk a little bit more about the activities. Right, although the activities work together to form a cohesive user experience, each one is independent of the others, and that's why the life cycle becomes so important. If permitted, a different app can start an activity in another app. Okay, and a little example there: a camera app can start the activity in the email app that composes new mail to allow the user to share a picture. So we have all these. When we talk about an application can be a single activity, can be a kind of multi-activity app. Okay, but each activity has its own life cycle, and again we will talk about that in a couple of slides. Okay, just to talk a little bit about the life cycle itself. Okay, to navigate transitions between stages of the activity life cycle, the activity class provides a core set of 6 callbacks. We have, and there they are here at the moment. So we have our onCreate. Oh, sorry, I'll give you a better color there. Give you some red for that one, highlight a little bit better for you. Okay, so we have our onCreate, onStart, onResume, onPause, onStop, and onDestroy. The only one that's required, and that comes by default when we create one, is our onCreate function, our onCreate method. All the others are optional and are only needed to be implemented as necessary when you as a developer require that particular callback to be kicked off within the life cycle of the application. Okay, so the system invokes each of these callbacks as an activity enters a new state. So if we follow it through here, to begin with, you can see it here. So we have, to begin with, the user would launch the activity, so they'd hit the actual your little launcher icon on your home screen. The first method that gets called is your onCreate. So whatever code you have in there will be executed, and when you've gone through the wizards and you add a new activity, you get that supplied by default, plus you get the small setup code that inflates the layout and then binds the layout to the particular activity. So at the very minimum, you are required to have this onCreate. Okay, all the rest are options. So by default, if we just had the onCreate, right, the default on start and on resume in the superclass activity would be executed, and then the activity is in its running state. Now, if, and this is sometimes can be hard to get your head around, if another activity comes in the foreground. Now, that other activity can be another screen within your app, or can be another actual separate app. So going back to the little example we gave, if the user is using your app, so your activity is running, and then a phone call comes in, so that other activity would be actually the phone app taking precedence over your app. So your app, right, would then go into on pause. But saying that, if the user was in your initial home screen app, the activity, should I say, and then the user clicks on a button to take you to maybe a report screen or a kind of a list screen, then that activity, that list or that report, whatever other activity, other screen within your app, comes into the foreground. So your initial home activity is paused, and it continues then to go through that life cycle where we have our on pause, user returns to activity, back to on resume. So most of the time, 90% of the time, I'd say, your activity or your app and your activities within your app are cycling through this on pause, on resume cycle. Okay, we've got the other use cases that if your activity happens to be stopped, so on stop would be called, right, and then it would get restarted again. So depending on all the different use cases that you might have, so if it's stopped, okay, we say, take the phone call as an example, your app is stopped, right, but the app with higher priority needs memory. So the phone, the Android operating system realized you need to be kept on, the call is of higher priority, so your app gets killed off, so the process is killed, so you potentially lose any data, and then you're back into the onCreate again. Whereas if the activity is only stopped, right, and then the user navigates back to that activity, it's restarted. Okay, so you as a developer just need to be aware of the full kind of life cycle and all the different methods that can be triggered depending on the particular use case that your app is kind of going through. It's only after on destroy is called that your whole activity would be shut down and kind of removed from memory. Okay, so but most of the time, just the main point to note is, most of the time you will work with onCreate, possibly on resume, possibly on pause. Okay, I suppose another example there, if you're connecting to the internet and you want to make sure that your data is most up to date, you might decide to put it in the on resume, right? Because if you happen to put it in onCreate, that will only ever be called again if the process is killed. So if you want to make sure that code is called every time the user returns back to that particular activity, that particular screen, possibly a list of data, you would put that in your on resume. But if you only want it ever to be executed the once on startup, essentially, you can place it in the onCreate. Okay, so there's quite a lot kind of to know about with that life cycle, but as a kind of a starting point, most of the apps we will be working on, you will only ever need to use it onCreate. It's only when your apps start becoming quite complex and maybe working with remote services that's when you need to be more aware of the other methods that are available to you to ensure that your app runs correctly. Okay. Other than that, I think that's that kind of wraps that up. So we've just the main references there on our developer docs, so you can get most of the information there about the components and activities and all your content providers and all the rest of it. So other than that, thanks for listening, and goodbye. Hello everyone, and welcome to today's lecture. So in this set of slides and this video, what I want to run through is a kind of a first look at that Placemark app. Okay, so the agenda for today is as follows. What I'll look at is the initial app setup. So this is before we make any changes. Okay, so what we get with Android Studio. We'll then look at the the structure of that app and some of the kind of most important files that you need to be aware of. We'll talk a little bit about logging support. We'll look at event handling, and then this automatic binding. Okay, so it's kind of view binding and how we can attach and how we associate our widgets with our code inside our activity. Okay, so to begin with, if you just look at kind of the setup, again, we would have covered some of this in the lab as well. So we're just kind of taking you through that. We went with the initial empty activity, and then just the configuration. So just be careful of that. So we're just making sure it's Kotlin. We would have discussed about the API as well, so we're sticking with Android 10. And then just kind of make note of the package name there as well. Okay, so that's initially anyway. That's the one package that we're going to put out our code inside. Later on, we will actually restructure that to make our design a little bit better. But that'll come to that in later versions. Okay. So in terms of that setup, what you get, right, and once you've configured the project, is a structure like so. Okay, so this is our kind of a screenshot of that initial application where we have our activity. We have our we won't be covering it really in any great detail, but just if you want to do some unit testing, Android testing, you can. There's some default files there for you as well. We'll have a look at the manifest file, and then we have our resources. Okay, so as we would have kind of covered previously as well, your application is kind of split into two parts. There's all your source code, which goes inside your Java folder, and then there's everything else basically that the user sees that goes into the res folder. So what we're talking about there is any drawables, your layouts. So in this particular example, we got the default activity _ placemark layout. So again, because we named our application placemark, we get by default a placemark activity and an activity _ placemark layout. Again, just points to note, must be all lowercase or the naming of the XML, so of the layout, and any resources for that matter. Look, if you notice, colors, strings, themes, they're all lowercase. So if you need to manually create one of those resources yourself, make sure it's all lowercase. Okay, but just going back to that, as well as the layouts and kind of images in the values, you can see it there. We have any colors that we want. We have any I suppose I can say it there, yeah. Any colors, any string resources, and in the particular themes. And then when we want to bring in our dependencies and add new dependencies, and we will be working with these files quite regularly throughout the module, we have our project and module build.gradle. So again, we'll have a look at some of those files in a little more detail later on. Okay, so just to kind of officially highlight those individual files. So they're the main ones we're looking at. We have our Android manifest, like I said, the placemark activity, which is where all our code goes, the source code. Okay, and then we will be adding in activities there as well, the layouts, and then the other separate kind of resource files that you mightn't need to modify too much, but if and when you're refactoring your application, you're bringing in new features, you may need new strings, new text that you want to be able to display to the user. You might want to change some colors. Even you might want to change the overall theme. That's where that all goes. Okay, so if we look at some of these files in more detail, okay, so here's the placemark activity class that we get initially. Not too much in it. That's basically it there. Okay, so our class extends from app compat activity, and again we'll look at that now in the context of the class hierarchy within Android Studio. We'll look at that in a minute. But what we do get is, and by default, and we need this at a minimum, is this onCreate function. Okay, and this is one of a number of different lifecycle functions that you can utilize and implement when building your application. But at the very minimum, you need an onCreate. Okay, you can have, there's an onResume, there's an onStop, an onStart. So these are other places where you can place code to react to changes within the application if necessary. Okay, but all we want to do here in this instance is there's a call to set content view, which identifies the r.layout.activity_placemark. So this is what we get by default. So when our application launches, this activity, placemark activity, will be kicked off, and in turn it will tie into the life cycle. So we will call the superclass onCreate within the life cycle, which again is tied back to that class hierarchy, which will be inside the app compat activity. And then from our point of view, we set content view, or we want to attach a particular layout with that particular activity. So for every activity that you create, and as we go through the module and the semester and we create new activities, if we use the wizard and use Android Studio, it will give us by default a new layout, which in turn will be the layout that's displayed when that activity is launched. Okay, again, remember, this is all by default. We haven't added any code as of yet. So in terms of the class structure, this is what we're looking at. So initially we have our placemark activity, but if we now bring in the immediate superclass, which is app compat activity, I'm just going to hide myself there now for a second. Okay, so we have our placemark activity, and finally, within the context of all base classes, you can see here we have our context, we have our context wrapper, a few other ones there, fragment activity, as we may come across this again as classes get a bit more complicated. So hopefully this kind of gives you an idea of the depth and the breadth of the SDK itself. So even though we have created, and what we're working with is this individual placemark activity, it is utilizing and working with a lot of other classes within the overall library. Okay, so that's just kind of a point to be aware of. But from our perspective, initially anyway, most of the code that we need to work with, we will be able to write and put inside this onCreate. Okay, we may, when we look at the lifecycle, we may bring in some and utilize some of the other functions there, but at the very minimum, all we need is the onCreate. So most of our setup code can be placed inside this onCreate function. Okay. In terms of some of the other files, the manifest file, again, this is kind of metadata about your application. So by default, here we have our application tag, which is the most important one. You can see it in here. So we have some kind of setup code or setup information about the icon that we want to use. So there's that launcher icon, the label, or the name of the application. We have the theme that's been applied. So if you want to change the overall theme of the whole application, you can set it up there. What's probably most relevant at the moment is this here, this activity tag. Okay, so the way the security model works within Android is that you have to make sure that, just come back to there now, you have to make sure that every activity that you want to be able to launch within the overall application has to be listed and referenced in the manifest file, in your Android manifest.xml, right? And coupled with that, what we're saying here is we have this intent filter, okay, which is basically telling the device and the Android operating system that this particular activity placemark activity is going to be the main launcher activity. So this is the first activity that when the application launches, this is the first activity that gets displayed. So as we bring in more activities, right, we may decide we want a splash screen to be the first activity to be displayed, or as will be the case in our application, a list of our place marks. That might be the first activity that we want to show. So we will need to modify this manifest file here to indicate that it's the placemark list activity, and we will come across that in later labs, later lectures. The placemark list activity will be our first activity to launch. Okay, so that's one of the most common changes that you might need to be making within the manifest file. Okay, we've also got our build.gradle. So you can see here information about some of the plugins that we're using. You can see, look, the compiled version. So we're working with Android 11 there, 30. The minimum SDK which we set was 10. What we're targeting, the version code and numbers, that's tied to if your app is, if you push it up onto the Play Store. Okay, so as you modify and create new apps and new features, add new features and what have you, and you want to push that up, you would need to make sure that the version number is different so that the Play Store can actually pick it up as a new version and automatically push out the updates to anyone who has it installed. But what we will probably work with most often are the dependencies. So there's a certain amount of dependencies there at the moment. You can see it there, working with the Kotlin library, the core KTX Kotlin extensions, material guidelines there, material. So we might check on that again. Might always make sure that's up to date. And as we now go through the semester and possibly need more dependencies and want to bring in features. For example, if you wanted to bring in Google sign-in, Google authentication, you would need to add that dependency in here. Firebase, for example, maybe you want to work with your Firebase database, Firebase storage. Those dependencies would need to be put in here. Okay. Now, as I say, for the moment, there won't be too many changes to make, but it's worth knowing that that's where those dependencies would go. Okay. Coming back to some of our the code, I suppose, if you want to call it that. Even though it's XML, this is how we render a layout. So at the moment, in our default activity underscore placemark, there is one single text view widget that has certain information, certain settings, and properties, I suppose, a width and a height. There's a bit of text. Most importantly, how it's constrained, because the overall layout is a constraint layout, so that you will get that by default. It's probably one of the most common layouts to work with, and probably one of the best ones in terms of how you want to lay out your widget. So I'd always recommend using a constraint layout. But at the minute, we just have a simple text view. We will change that as we work through the weeks and work through the module. But for the moment, as I say, this is what we get as the setup code. Okay. Along with that, we have our colors. So you can see it there. All the kind of default colors that Android are supplying at the moment. They tend to change these quite often. So just because we have purple there now and kind of teal, they may decide that default colors, they want to change them again. So with new Android updates, Android Studio updates, they may get changed. So you can change these quite easily. You can, if you know an exact hexadecimal, you could change it there. You could actually bring in a whole new resource. Okay, and I will do that in the labs which as well. So some of the instructions are to bring in new colors, so to add as opposed to replace what's there already. But there's a very nice feature in Android Studio where you can simply click on the color itself and it will bring up a small little palette where you can go in and you can adjust those colors if you want. Okay. To finish off with that, we have our themes, and we look at strings down in a minute as well. But the theme here, this is basically the overall look and feel of the application. Okay, so at the moment, it's day night dark action bar. we will possibly modify that, and there's references to those color settings as well. So the color primary, the primary variant, these are all just again the properties of that overall theme, and if you want it, you can actually come up with your own theme. Just make sure you place it inside that themes.xml. okay. And finally then we have our strings.xml. This is where we place any string resources, and again, it's always good practice to have string resources in your application as opposed to hard-coded values. Okay. And again, that's something I will be taking you through in the labs, that I will give you string resources for you to add in. So be careful about cutting and pasting XML, okay? Just make sure you don't delete any kind of tags. Even something as simple as that being deleted or removing this by mistake, excuse me, will cause an error in the XML, will cause an error for it to build, and will cause a lot more problems within the application, okay? Now, again, one point to note also, you don't have to work with the XML directly if you don't want to. You can design all this through the visual editors that Android Studio offers you also. It's just that in the labs, I will kind of, to help speed things along a bit for you, I will give you the XML that you can replace and overwrite, okay? So something else could be worth just being aware of: the logical versus the physical view of your overall application. So here's the project as it's seen in Android Studio, right? But if you were to actually navigate to your Explorer, whether I'm on a Mac here, so this is Finder, or it could be your Windows Explorer, that if we look at the say the layout, for example, that's inside that the layout folder, which is inside a res, where the corresponding one is over here. So we have the overall placemark folder. There we have a corresponding res folder. There's our layout folder, and there's that same physical file. Okay, and again, been listed as an XML document. So if you need to get in at those files independently of Android Studio, that's easily done too. So, but again, it's worth just being aware of the different and how it's structured, I guess. Okay. In terms of our design, so just make sure that you have this. We kind of start making some changes now. So just make sure that your material guidelines or your material dependencies are the latest one. So currently this was 1.3, but again, that might change. Here we are changing our theme. So you can see it there now. We're bringing in the .no action bar, and again we will revisit that later on as well. And we're bringing in some extra colors. So we're changing some of the default colors there. So I'd ask you to bring those in and update those within the colors.xml during that lab. Okay. So if we look at what's generated by Android Studio, so there's that same. There's the text view widget inside our layout. There it is actually rendered when it's displayed. Okay. What we get when I ask it to bring in and work through the different versions, on the face of it, it doesn't look like much. That there's just one edit text to add in, and there's one button to add in. But in terms of the layout, it's quite substantial. So this is what's behind the scenes. So if you can see it there, we have it all inside a relative layout. We're working with an app bar layout, which eventually will tie in with that toolbar there. You can see it there. There's the toolbar. We have a scroll view. We will need that later on, because as we add in extra features, extra widgets to our layout, we may need to scroll down through this layout to be able to access and get at the windows or the elements. And there's our edit text, and there's our button. Okay, again, you would kind of have run through that in the lab itself, but you can see yourself a lot of XML for quite minimal updates to the layout itself. So it is worth getting used to working with XML and being able to modify it both in XML and the visual editor itself. Okay, just a little bit about logging. We're using Timber. So again, that will be one of the dependencies that we need to bring in. So there's the dependencies, and here's how we use it. So we to begin with, we say timber.plant. So there's that function there to essentially set it up and tie it to its debug tree, and then we can use quite nice little messages to give us kind of some feedback as a developer in Android Studio in the logcat to see what's going on. Okay, so you can see there's a little example there. This is what we would get. So even though there may be no interaction yet with entering data and all the rest of it, this will be part of the lab. We can still see that if and we can confirm that the activity starts correctly, and we will do the same with buttons getting clicked and so on and so forth. Okay, if you want to find out more information about it, you can get it there. There's a whole README file that's up online. But we will be using this Timber for logging for the rest of the module. Okay, it's kind of handy, really. Okay, so if we look at an updated class diagram, okay, so here we have now, here's our app compat as before, and it's our place mark, but now we're using this Timber library, so we're making use of that within our overall application. So there it is. We're just kind of setting it up, and then we can use it and use the messages. That's only one. That's I for information. There's loads for, you can have ones for kind of a full stack dump, just for debugging, for error handling, whatever. Okay, we'll kind of keep it simple for the moment anyway. Now, to talk a little bit about view binding. So this is the most recent approach that Google are taking in terms of how they associate their and tie their widgets to their UI. Okay, so there's a couple of steps you have to follow. Number one, just confirm that you have your build features, that your view binding is turned on. Okay, and what happens is, for every layout that you have, okay, there's an automatic class generated based on that naming, which will allow you to reference excuse me, the widgets on your layout. So in our example, we had our placemark activity, and then we had our activity underscore placemark was the layout. Okay, so what we get is this activity placemark binding new class, an auto-generated class. So it's the name, it's the layout, activity placemark, and then the keyword binding appended to it, and that gives us then a reference to all the widgets that we need to get at. So the approach that we're going to be taking is initially, and again, this is the kind of the Google recommended approach as well, that we will declare a variable. So I'm just calling it here, calling it binding here at the moment, of that type. Okay, and within an activity, that then gives us direct access to the widgets. But before we can do that, we have to modify how we inflate the layout to get at it to begin with. So here we are saying our binding is assigned activity placemark binding dot inflate the layout inflator, and then instead of directly accessing the layout, we access the root element of that new object that we have. So we say set content view binding dot root, and once that is done, and this should be done inside your on create, once that is executed, we now have direct access to all those widgets via the binding object. Okay, so we can access the layout widgets through that binding instance. Okay, so to look at it in examples, in terms of our event handling, we have on our activity, we have this whole button. The button's ID is button add, and again there it is, look, activity underscore placemark. So we can say binding dot button add, and then dot set on click listener. So that's how we kind of add some basic click event handling to that simple widget. Okay, and that essentially is how it works. So no matter what the name of the widget is, once you give it a proper ID and that widget is on that particular layout, you initially inflate that layout through the auto-generated class, set it up as an object, and use that object then to access all those individual widgets. Okay, so that was the event handling. To look at it in the context of the overall class, so here we are inside our on create. Here we are. There's the binding setup. There's our logging, and then again all inside the on create, there's our event handling. So that binding there is accessing directly the button add widget on the layout. Okay. To look at another example in a little bit more detail. So when we want to get at that edit text and the title element of that edit text. So here we are inside our, again, event handling. So when we click on the button, we want to update a local variable placemark title, and we say binding dot placemark title. So there's our overall edit text, which is placemark title, the ID of placemark title, and through that same binding instance, we can get at that, in this example here, the text property of the placemark title, and then we convert it to a string because we want to store it as a string and process it as a string. And we do a little check there. Once it's not empty, we can log it to the screen. Otherwise, we use a little snack bar to tell the user, please enter a title. Some very basic error checking, error handling, but it does the job. Will inform the user that they need to enter a title and won't accept empty values. Okay. What we then moved on to was bringing in a model. So that was again working with kind of raw data. So we modify our application a little bit. So we brought in a new package called activities. So put it inside the org.with.placemark. Okay. And then we brought in a models package. Okay. And inside that we placed our placemark model class. And this is a particular type of class. It's a data class. So we declare it like so. Data class placemark model. And again, we would have covered some of that in the Kotlin material in terms of all the extra functionality you get with a data class as opposed to a regular class. To begin with, it's very simple. Just a single property, a string called title. In terms of how we use it then, how we utilize it. So we now, as well as our binding element to access the widgets, we now create a new placemark model object called placemark, which at the moment has a simple title field. And how we use it then is, instead of, as we did in the previous couple of slides, assign a basic value, placemark title, we now assign the text that the user has entered, the title the user has entered, to the title property of the placemark object. Okay, which we can then go and use as necessary. And again, we can modify it there slightly, and we do our check just to make sure that the user has entered some information. Okay. In terms of the overall project and the kind of our class diagram. So if we look at it here, this was our initial app compat activity, which is the superclass for our placemark activity. So that one extends from the other. Here we are bringing in our timber, and now we have our placemark model class been introduced. So we're utilizing a number of different classes, whether we're extending or whether we're using. Okay, so that's the class diagram at the moment, and as we work through the weeks, this will actually grow quite considerably, so that you get a very good idea of, as I said, the depth and the breadth of the whole SDK. Okay, just a little recap on what we've brought in new into this version. Okay, so we have the binding and declaring our object. We have setting up that binding. Okay, and that's important there. So the naming convention is quite important. Okay, so irrespective of what the layout is called, right, once your application builds and you have widgets on it, a class will be auto generated, tied to the layout name, and binding appended to the end of it. So what we will see later on in our placemark list activity, we will have a placemark list, or to be an activity placemark list, an activity placemark list binding, because that's the approach that's the convention that has been taken here. So that the binding keyword is appended to whatever your layout naming is. Okay, and then it gets inflated via the layout inflator instance, And then instead of setting the layout directly, we set content view on the root element of that. So you will be replacing, when you need to bring in the view binding, you will need to replace those calls. You can't, we would run into a lot of errors, a lot of issues if you try and leave both calls in. So it's very important that you replace that call with this particular code here. Okay. And again, how we use it, there's our binding element, there's our button add widget, there's our place mark title widget, and again both being accessed via the binding element. Okay, so not much else there really. That kind of concludes that first look at our place mark. Not much going on. Just again, I suppose just to find one there. There's a little example of the snack bar. Again, this is now the recommended approach with apps, that the toasts are been kind of phased out a little bit. So they're favoring snack bars at the moment. Okay, so that's why we're going to use those as well throughout the module. All right. Other than that, some references for you there, just kind of the main developer docs. So thanks for listening. Hello everyone. So welcome to this short video on a run through of the solution to our placemark version 1, including the exercise. Okay, so this is something you can have a look through if you're running into any difficulties with finishing off those exercises for that lab A02, the placemark version 1. Okay. And what I actually wanted to leave it this way, because I just want to draw your attention to something that has happened a few times. So I said I'd actually put it in the video for you. So if you look at, just take a note of the version there, it's 4.2.1, and this seems to be a common issue that's cropping up at the moment on the forums and what have you. Okay, so if we open up our project, just close down that window there. And again, if you see it there, if you get your plugin, so we'll update that first. So we'll begin upgrade. So it's just building up there now. Excuse me. Actually, don't worry about the git, because this is a solution that I've just pulled down from the site. Okay, so this is essentially what you'd be working with as well. Now, so if we expand our application, excuse me. So we have our activities, and here's our model. So we look at this now in a minute. What I want to first mention is this issue with rendering the layout. So if we open up this. If you get this, okay, so it's actually not rendering for us correctly, okay, what the fix seems to be, if you look it up here, you can see the errors as well. So you get down here as a render problem. There's an option down there to disable the experimental layout rendering engine. Right, a few other options you can try. One nice one actually is up here, and you can do a force refresh layout. So if we choose that, that's not going to make any difference. But what the issue is in the code itself. And so at the moment, with that 4.2.1, if you go to your edit text, okay, and if you notice that we have an autofill hints that's in there, and you get that by default when we add in an edit text. This is a property that's automatically added, but for some reason it is causing issues with the rendering of the layout. So what we can do is, excuse me, so if you happen to get this error and you do have that autofill hints property in there, just remove it, okay? And now if we go back to our design, we're all good. Okay, so we can see our design. And again, I'll just collapse a few windows there so we can get a proper look at it, okay? So what I want to run through then is just a quick look at the application itself. And the including the exercise that you would have had to work on. Okay, so if we look at I suppose we can work back the way, seeing as we have the screen open. So if I just maximize that window for a second there, so what we're looking at here is we have our initially we had our placemark title, and what you were at, one of the exercises was to bring in a description. Okay. So that when we go and add our placemark, that we store a title and a description. So when the user enters the title, title's added, description's added as well. So where you a good place to start would have been our strings.xml. So if we just go back there for a second. So let's open up our strings. So again, so at the moment, we would have had to add in this new description. Okay. Now look, you can call it whatever you want really, but just to kind of, if we're following what we had there, we hint place mark title, hint place mark description. Okay. And there's kind of like all the strings necessary for that solution. So we would have on top of the app name, which would have been there by default, for the final kind of solution, including the exercises, we have our text for our button, our title, the hint for the title, and a hint for the description. Okay. So then you would go back to your layout itself, and you would bring in a new edit text, very similar to what you did with place mark title. Okay, so you can see it there. There's our description, there's our title. Now, so if we look at the code, actually, sorry, if we just see it in our component tree first, you can see it there. I think if we just drag that across, we can, there we go. Just so that we can actually see that within the component tree, we can see the references to the text that we want to display. So that there is actually referencing the add place mark. So the component tree is quite a useful window to keep a track of, so that you can see where and how your widgets are laid out, and the names, and as you see if you roll over there, and the types. So if I roll over my button, to come up as a button. Okay. So again, let's go back to where we'll expand our layout, and if we go in and look at excuse me, the code. So initially, there's our edit text, a couple of properties, just a color, and I suppose there's the one relying on the string resources. So there's the hint, and likewise we do exactly the same for the description. So if you notice here, okay, the color's gone a bit mad there again, and we put it back to our red. Okay, so just the most important thing for us, I guess, and from like kind of tied to the notes as well, we're calling this, the ID is description. So when we need to bind to this, it'll be via that binding element, and it'll be that binding dot description we'll be getting in at. Okay, so we'll look at that now in a minute as well. But all the rest of it is more or less the same. So you can trick around excuse me, with the margins if you want. The max length there we're setting is 25, but again, you could make it smaller, make it longer if you wanted to just experiment. And again, the text size, just kind of the default one there as well, would have been the same as our title, which is 14. Okay, so that would have been working out the layout. And again, you can go back to your design just to see it in what the user would see. Okay, so there's our overall design. We would then, and you would have had to then go back to your model, would be the next kind of stop. Okay, so if we look at our model, we now have, as well as our title, we're now bringing in a description. Okay, so what that will allow us to do now is within a placemark model object, we can now store and maintain a title and a description property. Okay, so we're in the next change I had to do. And then back in the actual placemark activity itself, go back to here, there's a few things we had to do. So the first thing was we still have our placemark model instance. We're still working with our binding element to be able to access the widgets. And the part of the exercise was to be able to maintain an array, or in this case, an array list of placemark model objects. So we would, as well as declaring the individual placemark model to get the information from the user via the UI, we would also have to declare an array, specifically an array list of placemark model objects, and we're going to call it placemarks. So now in our code, so when the user clicks on the button, so again, let's look at our event handler. That's the whole lot there. Okay, and actually what we'll do is I'll expand that window as well. What I'm doing there, I'm just double clicking, quick double click, and again, a quick double click to collapse it again. Okay, so to look at it properly, look at our full button, the click, the event handler tied to the button. There's the whole lot. There's everything. Again, remember this is inside now our on create. Okay, so the lab would have involved accessing the title. The exercise would have required you to access the description. So again, very similar to the title. You can see it there, binding.description.text. Again, we're getting at the toString because we want to actually get it as a string property, because our description property of our placemark object is of type string. Okay, and then our little check, once we know the title is not empty, we could, if you wanted to be very complete about it, you could also do a check on the description as well. But just for this particular use case, once we have a title, we can continue on. So technically the description could be empty and we could still go ahead and add it, but that in this particular case, that's okay. And most importantly, we add that placemark element to the placemarks used via the add function. And if you notice here now, we're saying placemark.copy, and that's very important. If we were to add just the placemark element itself, we would be, and then going and when the user would add a new one, we would be changing and updating the same placemark instance. So when we deal with passing objects, they are passed by a reference. So what we need to do is make a copy, and because this is a data class, we actually have access to the .copy function. So that will create a true copy of placemark, which will store a separate instance inside our array list of placemarks called placemarks. So when we go and ask the user for another title and another description and then add that placemark, that is a separate instance again. So we get 3 separate copies if it's 3 objects that we happen to add in. And again, just for kind of just a little bit of kind of completeness, we just run through, and using Timber, we just display each element that's added to the console. Okay, and if we don't have a title, we are using a snack bar. Okay, so if we just, what we'll do now is we can actually just run this just to see it in operation. So again, just going up here, at the moment I'm using an Nexus 5 here, API 30. Just going to run that. If you can keep an eye, you see the Gradle build is running there. And what we'll need to do is probably need to keep an eye on the logcat. So I'm going to open up that logcat window. So you can see all the messages flying back between there, the emulator and the Android Studio itself. Excuse me. So again, Gradle build running. Again, I wouldn't worry too much about any. You'll see a lot of red messages popping up. They're not too important at a startup level. Here we have now. So here you can see it there over on the right hand side. We have our title field and our description field. Okay, so again, just for testing purposes, if I was to try and add a placemark with no title, I should see my snack bar pop up, which I do down the bottom. Please enter a title. So now we can do please enter a placemark title. So done more, for argument's sake, description. Sorry, Lovely, lovely bars, lovely restaurant, yep, lovely bars. Do add, and if we look it down over here, we can see that if I just scroll across it a little bit, we'll highlight it for you. Here we are using our Timber to display the information to the user. So here we have the add button was pressed, and we're displaying what was pressed, and we're also then displaying, and again notice we're saying it's inside the onCreate. So our Timber is quite useful here. Information, we can see what class it's in, what function it's in, and then what we want actually printed out. So that placemark first element, placemark 0, has a title of done more and description. So if we go back and we do this again, and we'll add a new one. Now we do have to delete back, so we would need to make sure. So we go through more. Again, local areas. Okay. Lovely beaches. and add, and if we go back over here to our logcat again, what we now have is in our add button is pressed with the individual information that the user has typed in, but also now via that for loop we're getting the place mark title. There's the first one and there's all our elements. So if we keep adding, that would keep displaying to the console. Obviously that's not much use to us, and not much use to an end user. So what the next lab will involve will be bringing in that list, placemark list activity, to allow us to display a list of these place marks as we add them. Okay, so it'll involve a new activity, using adapters, recycler views to display that information to the user. So it'll make it a little bit more user friendly, a little bit more interactive. Okay, so other than that, I think there's not much else to mention in the lab itself. We go back to our project. So that's the structure itself. There's a placemark activity, there's our model, there's the layout itself, the colors. I suppose, yeah, we would have added in some new colors. So again, just kind of note that there. Okay, so we had a color primary dark, color accent. If we wanted to see that teal, if you notice over here, that when the edit text is active, there's that teal color popping up. So if you wanted to, you could possibly change that here. And again, while we're here, I might as well show you how to do it. What we do is we can actually click on that and it pops up. And then I can use my slider and I can move it around. So even if I leave it there, for argument's sake, and click away, so we can see it now, that color has changed. And here we go, we may as well just test it while we're at it. So I can relaunch. Again, I don't need to shut down the emulator. So that's just one kind of top tip, if you want to call it that. Once you launch the emulator, you can leave that emulator running, and every time you rebuild your application and you want us to deploy a new version of your application to the emulator, to that virtual device, it will uninstall the old one and reinstall the new one. The only reason you would need to shut down that emulator and possibly restart it again is if you notice some discrepancies between your code base and your emulator. So for argument's sake, in this instance, we've changed the color. We should see that color change over here. So if you run that, so I can restart again, run the app. Shouldn't take too long. There we go. Okay, so now when I select this, go back over here. See, notice now our active edit text is now that darker blue, which I suppose is a bit nicer and it kind of ties in a little bit more. Or we could actually change it to the original color. But that's, again, very quickly, and how easily we can change the look and feel of our overall application. Okay, so look, if you have any questions on it, you can get me on Slack or over email, and I will talk to you again next time. So thanks for listening, and goodbye.